Okay, good afternoon, all of you. Yes, so let us be introduced to new members of learning. So last, this kind of thing in your day, last year possible. What did you want to say? And what is also? 60 and 70. 17. What you got 60? 17. 66 10. 66 10. 66%. So then very important. What is the name of college? You completed your diploma. You still don't know the name of college. How? What is the name of college? Is it the college of engineering? What is the name of that college? Huh? At least don't say just swimming. We also know there is a college in swimming. When anybody will ask you from what do you do? What do you do? And here, yes, no.
My name is Savannah Sawali, and I am from I have completed my diploma in government polytechnic and organized the something last semester.
Good introduction by. Who's our from GP? Okay, so up to this point, we have covered some of the components of the power plant. We have covered boiler, then we have covered condenser, right? Today we are going to start compressor. So you might be knowing what is compressor, right? So if you see natural phenomena, naturally kind of aspect, liquid flows from high pressure to low pressure, or air, if you take it also flows from high pressure to low pressure. All those hurricanes would happen in the ocean. So these are the result of there is some pressure drop at some region, and at some point there is a high pressure. So air flows from high pressure to low pressure. So that is a natural phenomenon. Or naturally you can say heat flows from high temperature to low temperature. So whenever there is a high temperature there is low temperature. So heat flows from high temperature to low temperature. So that is by natural means. But what if you want to do reverse way? What if you want to transfer heat from low temperature to high temperature, or you want to transfer liquid from low pressure head to high pressure head? So in that case comes compressor and pumps, right? So what is the difference between compressor and pump? So again, fluid comprises of both gases and liquids. So pumps is for liquid and compressor is for gas, right? So whenever you want to do reverse process, naturally liquid flows up and might take high level to low level. So while levels are also the characteristics you need a compressor of pump. If there is a water, you need pump. If there is a gas, you need a compressor, right? with that introduction, we start today's lecture related to reciprocity air compressor. So your syllabus is very much limited to reciprocity air compressor. But in actual, there are many compressors. So there are rotary compressors, there are reciprocity air compressors. So there is a centrifugal compressor. Okay, so first we'll see the classification of compressors, and then we'll check the reciprocity air compressor. Okay. So these are the contents we are going to study. Use of compressed air, then the work done to drive the compressor, effect of clearance in the reciprocating air compressors, need of multi-staging, then volumetric efficiency, condition for maximum efficiency, and lastly intercooling. So intercooling is a part of actually multi-staging. When you go for multi-staging, that in that automatically intercooling comes into the picture. Okay, so this is CO10. Okay, so air compressors. So specifically, it is mentioned. No need to mention air because when we say compressor, it is automatically related to gases. Correct. So compressor, it is a device which takes a definite quantity of fluid, usually gas or mostly often air, and deliver it a required pressure. Okay. So we have inlet to compressor which sucks the air, compresses the air, increases its pressure, and then this increased pressure air it is stored into the cylinder. So whenever we say compressor unit, it has compressor plus storage tank. So if you see in our workshop also, there is a air compressor there and there is a storage unit also there. If you visit any automobile workshop, so that time you might have saw. So there is a compressor is also there. Attached to that, there is a storage tank is also there. From storage tank, you take the air through pipe, and then it is passed into the tubes of the tires. Okay. Air compressor takes in the atmospheric air, compresses it, and delivers to storage vessel, that is reservoir. So compression requires work to be done on the gas. So whenever I say work done on the system, it is a negative. Whenever we say work done by the system, it is positive. Whenever I say heat is transferred to the system, that means positive. Heat is lost by system, that is negative. Okay. So compressor must be driven by some sort of prime mover, that is engine. So in some cases we can use electrical energy directly, or in some cases we first use diesel engine, and that output of diesel engine is connected to compressor, and that way air is compressed. Okay. So there was very funny photo was there in newspaper. So Pune Municipal Corporation, they employed electric buses to promote electric vehicles, and there was photo that electric vehicle was charged by a diesel engine. So reverse should not happen. We are trying to not to use IC engines. That is why we are going for electric vehicles, but reverse should not happen. So like in this case, compressor can be driven by an engine. So there can be a diesel engine which shaft is connected to compressor shaft and the air is compressed. Or you can directly use electricity, right? And that way we can compress the air. So how they are different from pumps? Major difference is that compressors handles the gases and pumps handles the liquids. So as gases are compressible, the compressor also reduces volume of gas. So I hope you know what is the difference between compressible and incompressible. So what is the difference? Now don't tell me compressible means it can be compressed, and incompressible means it cannot be compressed. So that much I know. So I'm asking what is the basic difference. So if I ask what is the compressor, don't tell me it compresses. What is evaporator? It evaporates. So don't give such definitions. Correct. So density changes. So in compressible, if you apply the pressure, density changes. In incompressible, density remains the constant. Correct. Liquids are relatively incompressible, while some can be compressed. So it depends on the phase in which the liquid is. Applications: compressors have many everyday uses, such as air conditioners. So whenever we say air conditioner, there has to be compressor. Okay. So we'll see in that detail laterwards. But whenever I say air conditioning unit, in that case we have a condenser, evaporator, we have a compressor, and we have an expansion valve. Okay, it is reverse of Rankine cycle. Rankine cycle मध्ये काय असते? We have a boiler, then we have turbine, then we have condenser, and then we have a pump. त्याच्या उलट केल्यावर रेफ्रिजरेशन युनिट असते. वरचा कंडेन्सर जो आधी जो खाली कंडेन्सर होता रँकिंग मधला तो एअर कंडिशनिंग मध्ये वर येतो. सो वी हॅव condenser, compressor, evaporator, and expansion. So we'll see that later. Next application is pneumatic devices. So wherever pneumatic and gas applications are there, in that case we use compressor. So actually we store the compressed air, and whenever the store compressor is required, then we use. So that is the pneumatics. Then we have home and industrial refrigeration. So mostly in refrigeration, compressor is a part of that refrigeration system. Hydraulic compressors for industrial machines, air compressors for industrial manufacturing. Okay. In some cases, we use that air. आपण जर CNC बघितले आपल्या वर्कशॉप मध्ये, तर आपण ते compressor वापरतो क्लिनिंग पर्पज साठी. जे काही मशीनिंग केल्यानंतर जे पार्ट्स राहिले असते, स्क्रॅप राहिले असते, ते रिमूव्ह करण्यासाठी आपण ती compressor वापरतो. So depending on the applications. Now we'll see classification of that compressor. Okay, so it starts with compressor types. The main classification is positive displacement and dynamic displacement. Positive displacement example is reciprocating air compressor. Positive displacement मध्ये काय होत असते? एअर घेतली जाते, आतमध्ये स्पेसिंग क्लोज केली जाते, कॉम्प्रेस केली जाते आणि मग कॉम्प्रेस एअर बाहेर सोडली जाते. सो देयर इज अ इनटेक ऑफ एअर, then compression of air, and then there is a delivery of air. So that is a positive displacement. Dynamic मध्ये काय असते? Dynamic example आहे centrifugal compressor. So continuously you are compressing the air and also delivering the air. So there is no, like, there is also inlet, there is also outlet, but in that case continuously we are compressing the fluid. Then positive displacement is further classified as rotary types and reciprocating types. So reciprocating types, you already know there is a piston and there is a cylinder. In rotary type, there is an outer casing and there is an inner wheel. So we'll see that images also. Okay. So dynamic type is classified as centrifugal type and axial type. Okay. So first we'll see dynamic type and then we'll see this type. Okay. So draw this diagram, or first you write down the definition. Have you written? Huh? So okay. So you give the title classification of compressor and draw this diagram. So further, you can see rotary types are, these are the examples of rotary types. So there is a lobe pump is, sorry, lobe compressor is there, screw compressor is there, liquid ring, scroll, and wheel type compressor are there. So in next slides, we'll see one by one. In reciprocating, we have diaphragm based, we have double acting and single acting. Single acting म्हणजे एका स्ट्रोक मध्ये एकदाच air deliver होते. Double acting means in one stroke, 2 times the air is delivered. Then we have a diaphragm base. Okay, so many of you may not know what is a diaphragm base. So I'll show. So see, suppose this is a front view of a flow channel. Okay, and this is a structure. Okay, so this is a closed diaphragm. So what you see here, this is a diaphragm. Okay, and this diaphragm can be actuated mechanically or magnetically. So when this diaphragm will open, okay, so when this diaphragm will open, it will be like this. Okay, so in this case, diaphragm has moved in forward, upward direction. So just the upward move, in that case, it creates a suction and the liquid is taken inside. Okay, so when it goes in upward direction, liquid is sucked. Sucked liquid. Parat the diaphragm close will, right? And when it goes in downward direction, so it pushes the liquid. So that way pressure is increased. So again, pressurized liquid is passed through this. So this is a diaphragm. It is a flexible material. It can be actuated mechanically, or it can be actuated by magnetically also. It is a diaphragm. Then dynamic is the further classified as centrifugal type, axial type. So we'll see one by one. So diaphragm type is used where there is a very low pressure ratio is required. So our heart also is the example of diaphragm type of pump. So if you see the working of heart, the animations of the check, so in that case you will see continuously that diaphragm is like moving upward and downward. So whenever it moves upward, it creates a suction, blood is taken in. Then when it moves in downward direction, blood is pumped. So our heart is the example of this diaphragm type of pump. It is a pump. Okay. First we see dynamic type of compressors. The dynamic compressor is continuous flow compressor. It is characterized by rotating impeller to add velocity and thus pressure to liquid. So this is a cut section view of a dynamic compressor. So in this case, you see there is a axial shaft is there, and air is sucked to get in here. Continuously it is compressed along the axle of this compressor. Then the compressed fluid it is passed to outlet. So this way, like continuously it goes on compressing the air and then air is delivered. Okay. There are two types of dynamic compressors: centrifugal compressor and axial flow compressor. So we'll see one by one. So this you may be very much popular with this centrifugal type of compressor. So in centrifugal type, there is an outer casing is there. Then inside there is a impeller is there. Outside the impeller there is a diffuser. In this case, air comes in axial direction like this. It falls on impeller. Impeller pushes the air outside. As it pushes the outside, velocity of air increases. Then at diffuser level, this kinetic energy of air is converted into pressure energy, and this high pressurized air it is passed through the outlet of the compressor. So there is a axial inlet and radial outlet in the centrifugal compressor. So it is used wherever high pressure ratio is required. High pressure ratio it can be about 10 bar, 20 bar. In that case, we use the centrifugal compressor. So it achieves compression by applying inertial process to the gas by means of rotating impellers. It is multiple stage. Each stage consists of an impeller as a rotating element, and the stationary element here it is diffuser. So outside this is a diffuser, inside there is a impeller. Fluid flow enters the impeller axially and discharge radially. Gas next flows to the circular chamber diffuser. Just as the velocity वाढते impeller मध्ये, so its kinetic energy increases. When it goes in the diffuser, this kinetic energy is converted into potential energy, and we have high pressure air, and it is supplied to reservoir, where it loses the velocity and increases the pressure. So you can watch the animation videos are also there in the YouTube for centrifugal compressors. Next is axial flow. So here initially previously there was axial inward and radial outward. In this case there is axial inward and radial outward. So that is the basic difference between axial and centrifugal type. So working fluid principally flows parallel to axis of rotation. Energy level of air or gas flowing through it increased by action of rotor blades, which exerts a torque on the fluid. So हे जसं flow होते त्या cavity मधून तसं हे जे blades आहेत that exerts some pressure on the fluid. It has the benefit of high efficiency and large mass flow rate. It requires several rows of airfoils. So these are the airfoils to achieve large pressure rises, making them complex and expensive. So these are complex and expensive. Mostly these are used in jet engines. तुम्ही जे मोठमोठे jet aircraft बघता त्यामध्ये जे compressors असतात. So these are the axial flow compressors. Okay. So up to this we have seen dynamic compressors. Now we'll see positive displacement compressor. So positive displacement compressors causes movement by trapping a fixed amount of air, then forcing the trap volume into the discharge pipe. So in this case, air is taken inside, it is trapped, it is compressed, and then it is supplied. It can further be classified as rotary compressor and reciprocating compressor. So here the classification is given: air compressors. Reciprocating means there is a piston cylinder assembly, air is taken inside, piston moves in to TDC, here it is air is compressed and then air is delivered. In rotary we have many types. So this is a vane type of compressor, air is taken inside, then vanes reciprocates in this grooves, and then air is compressed and it is passed to outward. In reciprocating, depending on stages of compression, we have single stage and multi-stage. Single stage means there will be only one piston and cylinder assembly. Multi-stage means there will be multiple compressors. And the second is number of sides of piston in operation. If in this case this is single acting, means only one side of piston is active. In double acting there will be another piston at the bottom. So two pistons will be there and there will be common crankshaft will be there. So that way it is a double acting. So rotary type, you can see here the working. So this is a casing of this compressor. There is this rotor is there, and this is the center of rotation. Now there is this blade is there. So initially the air is taken inside. Okay. Now as this rotor moves, the air is compressed and then it is supplied at the outlet. So this is the outlet. So air is taken inside, then it is compressed in the periphery, inner periphery or inner surface of the casing, and then it is supplied to exhaust. So this is the working of rotary compressor. Gas is compressed by rotating action of roller inside the cylinder. Roller rotates off center around the shaft so that the part of roller is always contact with the cylinder. Volume of gas occupies is reduced and the refrigerant is compressed. So it is used where the refrigerant is there. Refrigerant gas. High efficient as sucking and compressing refrigerant occurs simultaneously. So when you use for refrigerant gas, that time it can be used. These are some animations. This is a vane type compressor. Air is taken inside and then it is compressed, and compressed air is passed to the outlet. This is a gear type of pump. Again, air is taken inside, it is compressed in this groove, and compressed air is delivered. So this is a working animation. Vane type compressor and gear type of compressor. Okay. So people have taken lot of efforts in this design. आपल्याला कधी कधी असं वाटतं की लोकांना असं सुचलं कसं असेल. सो नाही का कसं त्यांनी डोकं लावलं असेल, काय केलं असेल. So the person who invented it, he is the great person. Other what do they do the optimization. त्यांनी इन्व्हेन्शन केलंय असं असं होऊ शकतं. नेक्स्ट येणारे सायंटिस्ट असतात ते काय करतात, ऑप्टिमायझेशन करतात. कुठला पॅरामीटर जास्त पाहिजे, कुठला पॅरामीटर कमी पाहिजे. So that is the further study, but the person who invents, he is always the great. So next is reciprocating compressor. So there is another figure, I think. So okay, introduction. So it uses piston driven by crankshaft to deliver gases at high pressure. The intake gas enters the suction manifold, then flows into the compression cylinder. It gets compressed by piston driven in a reciprocating motion via crankshaft, and it is discharged at higher pressure. So I hope you know the nomenclature here. Outside this we call it as cylinder. This is a piston. This is a what? Piston pin. Then we have this crank. Then we have a crankshaft. Okay. So this is TDC and this is BDC. So piston moves from TDC to BDC. So suction valve is open. So through suction valve, air comes inside. Now when it reaches to BDC, both valves are closed. So when again piston moves in upward direction, when it achieves the discharge pressure, then this discharge valve opens. असं नाही की ते आता वर चाललाय म्हणून लगेच valve open झाला, असं होत नाही. आणि खाली लागलाय म्हणून suction valve open होतो, असं होत नाही. So it is very difficult to understand. Okay, pay attention. Mostly students हे समजत नाही. So when the piston is at top and it is moving in downward direction. Okay. So when it is moving, at that time suction valve is not open. So it requires to create a certain suction pressure. ज्यावेळेस एक certain suction pressure create होतं, त्यानंतरच suction valve open होतं. असं नाही की आता piston खाली चाललाय, मग suction valve open झाला, असं होत नाही. It has to create a certain suction pressure, then this valve is open. Then air moves inside, then piston reaches to BDC, bottom dead center. आता second misconception स्टुडंटचं काय असतं की piston ठीक आहे, आता BDC to TDC मूव्ह लागलाय, त्या discharge valve open होईल, असं होत नाही. Again, when piston is compressing the air, after it achieves required discharge pressure, required pressure that create होईल cylinder मध्ये, त्याच वेळेस discharge valve open होतो and then this air is taken out. Okay, so please take care. असं नाही की piston खाली लागलाय म्हणून valve open झालाय, असं होत नाही. It has to create a certain suction pressure. Again in this case, असं नाही की piston वर चाललाय म्हणून valve open झालाय. It has to create a certain discharge pressure. Okay. So this is a working animation, suction, compression, and then discharge. So figure shows single acting piston actions in the cylinder of a reciprocating compressor. Piston is driven by crankshaft via connecting rod. At the top of the cylinder are the suction valve and discharge valve. A reciprocating compressor usually has 2, 3, 4, or 6 cylinders in it. So here it is, we have single cylinder, single acting compressor. Okay, this is single cylinder, single acting compressor. So this is a connecting rod. Sorry, by mistake I called it crank. So it is a connecting rod. Here we have crank and then there is a crankshaft. So see here. So what I was telling previously, piston now is at TDC. Now it moves downward direction, and here it creates a suction pressure. So when it reaches here, then and then only the valve is open. Now when valve is open, air is taken inside and it reaches to BDC. So this is a BDC. Now it moves in upward direction, and when it reaches to this position, discharge pressure is created, sufficient discharge pressure is created, then discharge valve is open and then air is taken out. Okay. So any doubt? So this is a suction stroke, then this is a compression stroke. Only 2 strokes are there in compressor. Sorry, reciprocating air compressor. So you can draw this diagram. Huh? Okay. Wait, so let us write the introduction. Okay. So up to which part you have written? You write this one. Positive displacement compressors. Give the title positive displacement compressor. So have you written up to dynamic पण लिहिलं आहे ना? नाहीच काय हा ठीक आहे हे लिहा पहिलं त्यानंतर पॉझिटिव्ह डिस्प्लेसमेंट. Okay. So in centrifugal type and axial type. Then we have positive displacement compressor. Okay. Suraj. Correct, right? So I think already you have written the classification. Okay. No need to go for rotary. It is not in this level. Your software is related to reciprocating air compressor. So you can write down this. If you understand the working, then only you can understand the PV diagram. There is a PV diagram for compressor. If you understand the working, then only you can understand the PV diagram. IC engine मध्ये असेल बघा wall timing diagram. Actual wall timing diagram and theoretical wall timing diagram. Actual मध्ये कसं असतं म्हणजे पिस्टन टॉप डेट टू बॉटम डेट जातोय. तर बॉटम डेटला गेल्यावर इनलेट वॉल क्लोज होतो theoretical मध्ये. आणि ऍक्च्युअल मध्ये वॉल पीडीसी ला क्लोज होत नाही. पीडीसी करून थोडं वर येतो ज्या पिस्टन. Then the wall closes. That is the actual wall timing diagram. It is very important. If there is a company comes for a recruitment, automobile type, so they are much interested in this wall timing diagram. Huh? Draw this diagram, this one. Okay, completed the, if you complete theory part, draw this diagram. Draw this free body diagram. Don't draw like straight line, horizontal line. Then show FBD diagram. For cylinder walls, you can take help of scale. Scale ने काढू शकता. कारण एवढं मला वाटत नाही perfection असेल. एकदम straight walls. Okay. So those are completed. Enter your attendance in the chat box. And then we'll stop. इथं रोल नंबर 1 ऑफलाइन मध्ये कोण कोण आहे? हा 13 नाही का? 16, 17, 18. हा पुढं नवीन 4. हा 67. हा तिकडे 28. हा 21. हा 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 आणि तुमचं किती? 67. Okay, so we'll stop here. In next lecture, we'll see what are the terminologies which are used in the compressors, like compression ratio, efficiencies, etc. Then we start with the PV diagrams. Okay, pressure versus volume diagrams.